simple reactions and complex reactions. Normally, most of the reactions can be classified as simple reaction and complex reaction. What's the meaning of simple reaction? Which takes place in single step. Any reaction which proceeded with a single step is called as simple reaction. Many steps involves are called complex reactions. Suppose the order which exists in between 0, 1 to 3. Suppose order exists in between all this. Then it is called simple reaction. When order is 1 by 2 or 1 by 3, likewise, or 3 by 2, then it is called complex reaction. What are all we have seen so far? Simple reactions are single step. Complex reactions are multi-steps. In simple reaction, order is 1, 0, either 0 or 1 to 3. In complex reaction, it is 1 by 2, 1 by 3 or 3 by 2. Then, no side reactions. Simple reaction involves no side reaction. But in complex reaction, many of the side reactions are there. In addition to the main reactions, some side reactions also takes place. Here, products are directly formed. The products are directly formed in simple reaction. But in complex reaction, the products forms one particular called as intermediate or transition state likewise. Then the transition state breaks to form product. Between reactant and product, one particular stage reaches, which is called as transition state or intermediate. Either the transition state or intermediate breaks to form the product. Transition state are highly unstable. That's why any of the reaction involving transition state are very fast reactions, because transition state can easily break to form the product. Intermediate will take some more time to break. That's why it's a slow reaction. So in short, all the fast reaction involves transition state. All the slow reaction involves intermediates. The difference between simple reaction and complex reactions is a very important 5-mark question they are asking. Now let's see types of complex reactions. Title: the types of complex reactions. Types of complex reactions. The very first one is consecutive reactions. The consecutive reaction. What's happening in consecutive reaction? A gives B and B gives C. While A gives B, the rate constant is called as K1, and B gives C, the rate constant is K2. Where K1 is the rate constant of first conversion, K2 is the rate constant of second reaction. This is the example. This is called consecutive reaction. The example is, suppose one particular chemical is like this. The CH2 has been repeated by n times. It is one ester. It is having two ester group. RCOO group is called ester. it has two ester group. So it is called diester. When it is treated K1, the very first reaction, this R could have been replaced by H. In the first step, the R could have been replaced by H. In the second step, R dash will be replaced by H. On both the sides, alkyl groups have been replaced by H. It is called consecutive reactions. Then second one is called parallel reactions. Parallel reaction. What is parallel reactions? How the parallel reactions have been taken? Simultaneously, suppose A is one reactant. Simultaneously, plenty of products have been formed from A. A gives B, that is K1. A gives C, K2. A gives D. Three different products have been formed separately from A. It is called parallel reactions. The example is, let's see one example for parallel reaction. Suppose this is a bromobenzene. One benzene having Br. It is called bromobenzene. When the bromobenzene once again brominated, bromination of bromobenzene. One Br attacks. Suppose if Br is going to attack this, already one Br is there and it has hydrogen at each corners. Suppose one hydrogen from this corner has been taken out and it combines with one Br attacks here. This is the reactant and it's a product. It is called ortho dibromobenzene. Ortho dibromobenzene. In another case, para-dibromobenzene could have been formed. Para-dibromobenzene. So, it is the parallel reaction. Bromination of bromobenzene. It's a bromobenzene. You are getting ortho-dibromobenzene and para-dibromobenzene in addition to that. This is one of the examples. Shall we see the another example? This is the very powerful example for parallel reaction. Now let's go for another example. Suppose one carbon connected with 3 methyl groups. Two methyl and OH. It has to be counted like this. First carbon, second, third and fourth. Methyl group is connected with the second carbon. So it is called 2-methyl. Totally 4 carbons have been counted. 4 means butan. OH is there, subbutanol. OH is connected with second carbon. So its name is butanol. 2-methyl 2-butanol. when it has been treated, you are getting two products. The OHH has been removed easily. Now look here, there are two possibilities. It is the dehydration reaction. OH and H will be removed. This OH and this H will be removed, one possibility. Another possibility, this OH and this H can be removed. Once again I am telling, this OH and this hydrogen will be removed, one possibility. Another possibility, this OH and this H will be removed. Let's see the first possibility. OH and H will be removed. So, when you are getting CHCH, you have got this. The counting has to be done like this. 1, 2, 3, 4. So 2-methyl. Next to the second carbon, double bond is there. 2-butene. Since double bond is there, it is butane, 2-butene. So in one possibility, OH from this carbon and H from this carbon removed. So a double bond has been formed there. Shall we see the another possibility? OH from here and H from here have been removed. So what will happen? CH2, double bond C, CH3, CH2, CH3. Now counting will be like this. Here also methyl group is connected with second one. So it is called 2-methyl 1-butene. These are the two examples of parallel reactions. Understood parallel reactions? Then opposing reactions. All the reversible reactions are called opposing reactions. Third, opposing reactions. Suppose A combines with B to form C and D, where Kf is the rate constant of forward reaction, Kr is the rate constant of reverse reaction. A combines to B, A combines with B to form C and D, forward reaction. C combines with D to form A and B, reverse reaction. Since the forward reaction and reverse reactions are opposing each other, meeting in opposite direction, that's why these reactions are called opposing reactions. Understood? Shall we write an example for this? So the example of opposite reaction. CO. CO means carbon monoxide. It is reacting with the NO2, nitrogen dioxide. So in forward reaction, these two combines. CO gains one oxygen to become CO2. NO2 has lost one oxygen, become NO. CO has become CO2 and NO2 will become NO. This is one of the example. Another example, cyclopropane. It is called cyclopropane. Kf by Kr. While breaking, it isomerizes to form propene. 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 Then the third one, 2 hydrogen iodide breaks to form H2 and I2. hydrogen iodide breaks to form hydrogen and iodine. These are the examples of opposing reactions.